my dear student. I'm Mr. Kitwala from Educare. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of a wave for the subtopic of the sound waves. As we observe, my dear student, before we proceed with our discussion, we should remember where we ended on the last session. On the last session, we tried to explain the subtopic of the motion wave motions, how the particles can move from one point into another point through the medium. That is what we tried to explain. And we said that the velocity of vibration of the wave must be equals to 1/2L times the radical of tension divided by the linear density. That is what we expanded on the last discussion. But for our today discussion, my dear student, we are going to look on the other subtopic, which is called the sound waves. Here on the sound waves, we are going to see how the waves of the sound can vibrate from one point into another point. So before we try to explain this sound waves, we should remember that on the wave, we say that the wave can be categorized into two parts. We have the mechanical waves and also the electromagnetic waves. But in the mechanical waves, the particle require material medium to vibrate from one point into another point. And we say that on the mechanical waves, we have example of the mechanical waves is this sound waves. And this sound waves, their particles try to vibrate parallel to the direction of the waves. That is what we explained. So if we see this definition of the sound waves, we have been told that sound waves are longitudinal waves detectable by the human ears. These are the sound waves that can be detectable by the human eyes, by the human ear. But it travels through the medium as the compression and also the rarefactions. Kwa hii ni amani of those longitudinal waves because their particle vibrate parallel to the direction of the wave, my dear students. And we say that this can be detectable by the human ears. Tunajaribu kuobserve kwamba mtu amekuita, akishakuita pale mawimbi ya sauti yatasafiri, yatafika mpaka kwenye masikio, atakusikia kwamba unamhitaji na mwisho wa siku utaweza kusogea. Kwa ile nayo kufanya wewe uweze kusikia voice kutoka sehemu moja kwenda sehemu nyingine, tunaita ni sound waves, my dear student. But it require material medium to vibrate from one media into another place. And also can travel through this compression and also the layer reflection tunaita kwamba kwenye compression zile particles zinakuwa zimebini picked together. It means kwamba zinakuwa zimebanana, lakini kwenye hii reflection hizi particles zinakuwa zipo far apart, kuna ka distance fulani ambao kana bini formed. That is what we tried to explain on the wave motions. So we have been told that their speed and also characteristics vary based on the medium and also the source. So in order to determine the characteristics of this sound waves, we should understood the characteristic that is based on this medium and also this source. That is what we have been told. On this sound waves, we have been told that it can travel through the liquid and also the solid. Kwa hiyo hapa inakuwa na tabia hizi, haya mawimbi ya sauti yanakuwa na tabia ya kuweza kusafiri either kwenye a solid object au kwenye liquid object. We have been told here, my dear students. And on this solid we have then on form 1 tulisema kwamba kwenye zile states of matter we have only 3 states of matter. We have solid state, liquid state and also the gas state. Sasa kwenye solid state tulisema kwamba hapa particles wanabini compressed together. It means kwamba hakuna distance kati ya particle moja pamoja na particle mwingine. That is what we have been told that this sound waves it must travel through the liquid and also the solid. It means that on the solid state, hapa ndo tunaelezea kuhusu compression, hali ya compression inavyokuwa inatokea, kwa sababu wale particles wanakuwa wamebanana, ndio maana try to hit it vibrate very closely. Lakini ukiangalia hapa kwenye zile liquid, wale particles wanakuwa wako very far apart. It means they are not compressed each other. That is what we say here, my dear student. But sound can travel in solid as both longitudinal waves pamoja na transverse waves. When we talk about the transmission of this sound waves in solid, my dear student, it should lie on the longitudinal and also the transverse waves. Lakini kwenye longitudinal, wale particles wanakuwa wana vibrate parallel to the direction of the wave. Ila hapo kwenye ile transverse waves, the particle must vibrate perpendicular to the direction of the wave. That is what we have been told, my lovely students. So they usually travel out in all directions from the source of the sound with an amplitude, a frequency, and also a wavelength that depend on the direction and all the distance from the source. So in order these particles vibrate, my lovely students here, we have been told that it should need the source of this sound. Lazima pawepo na source, sehemu ambao sauti inaanzia, lazima pawepo na source. It means baada ya kuwa na source, ile sound itabini transmitted, itabini vibrated kwenda sehemu nyingine ambapo inabini required to attain, my dear student. But during the transmission, we have been told that they have that sound should require this amplitude. Lazima iwe na amplitude, kwamba kuna maximum amplitude pamoja na minimum amplitude. Also it should require the frequency and finally the wavelength. But all of this, the source of the sound, the amplitude of the sound, and also the frequency of the sound, plus this wavelength of the sound, must depend in the direction. It must depend in the direction and also the distance from the source here. So the displacement and also the pressure on the particle in the medium. This displacement and also the pressure on the particles in the medium is shown in the figure number 80.9, Roman A, Roman B, and also Roman C. This figure, it is going to explain how this displacement and also the pressure of the particles can happen, my dear students. So at the node here, any the particles at the medium. If we look for that figure, on the node we should observe that at the node we should observe that the particle is at the minimum. It means itakuwa kwenye minimum media au kwenye equilibrium position, ndio tunazungumzia hapo. Lakini kwenye antinode inakuwa ni very inversely. Hapo tutakuwa tunazungumzia kwamba wale particles wanapokuwa wana attain the maximum point, ndio tunazungumzia kuhusu ile antinode. Kwa yule particles wanakuwa wanalai kwamba lazima to look for the nodes and also for those antinode, my lovely student. But for the node that particles vibrate at the equilibrium position. It means kwamba wapo kwenye equilibrium position ambao displacement yao ni sawa na sifuri. But at that antinode we have been told that it means we are talking about the maximum displacement. Ndio kitu ambacho anaweza kukizungumzia hapa, my dear student. And we have been told that at the antinode here, at the node the pressure is minimum. It means the pressure is a maximum. Kwa kwenye node pressure itakuwa ni maximum, lakini ile amplitude itakuwa ni minimum. Lakini kwenye antinode ile pressure atakuwa ni a minimum, while that amplitude is a maximum. Kwa hivi vitu vinakuwa vina take place inversely, my lovely students. So after there, let us try to look at these examples of source of sound waves. Let us go and see the examples of the source of this sound waves. This include the brass. It must include the brass. It include the pipes and also the turning fork. Hizi ndio mifano mizima ya zile sound waves. The sound waves can happen, my lovely student, on this brass, on this pipe and also on the turning fork. So in this session, you will learn how to derive the velocity in the sound of the sound in material. Here we are going to see how can we derive the velocity of sound in these materials. We should determine the velocity of sound in air and also describe the application of mechanical vibration and also the waves, my lovely students. So by saying that, let us stop here. We should come and proceed with the next part, my lovely student.